So meet PolkaVM. PolkaVM is a RISC-V based general purpose virtual machine. RISC-V based means it's a register machine, and its instruction set architecture looks like a lot like RISC-V. We made minor modifications to it, mainly to make it more on-chain friendly, and it supports the RISC-V embedded instruction set architecture. And so what you do is you just compile your programs to the CPU, and then our linker translates it into a PVM blob that then is executable by pallet-revive. PolkaVM provides very efficient compilation because RISC-V is very close to x86 bytecode. So all those hard annoying problems, compilation problems that we have with WebAssembly, they actually just don't exist. So we can compile those programs much faster. And it also means that we can let LLVM or whatever good compiler framework spend a lot of time off-chain producing like very, very optimized blobs. So this means we have like very efficient compilation, and the contracts we are execute are actually like very optimized and fast. And yeah, PolkaVM also has gas metering with a gas model suitable for contracts, which not all WebAssembly implementations have. So as it is a standard, if you have portable code, for example, JVM or also Node like the V8 engine does this, you can actually either interpret or JIT compile the PVM blob. Interpreting it means you can start execution instantly like the EVM does. So interpretation is obviously also much slower, but it might not matter because, as I said before, if your contract does not do a lot of work, like interpreting it will always be faster than compilation. But if you also can compile your contracts, yes, you pay a fixed upfront overhead, but after compilation, your code executes much faster. It executes in near native code speed, and with this I mean actually near native speed, not as we'll see in some benchmarks. And contracts on Polkadot Hub will support both. We just start with the interpreter, and the JIT compiler will follow later. So what this translates is more or less whether to use the interpreter or the compiler is kind of an optimization problem. So if you don't have a lot of iterations, as you see on the bottom left, you might want to use the interpreter because that's faster. But the more iterations your code does, so if you imagine something like calculating Fibonacci numbers or calculating a hash, then like the more iterations you have, eventually will reach a tipping point where it might be worth to use the compiler. And here are some benchmarks. So what this does is it executes a NES emulator, and so we can compile this. It's called Pinky, and we can compile this Pinky NES emulator to various virtual machines. So we have the PolkaVM recompiler, the PolkaVM interpreter, Solana, RBPF, and WASMI. WASMI is like what the old contracts, the WebAssembly-based contracts palette uses. And we also have WASM time here, which is what parachain validation function uses. It's like the state-of-the-art WebAssembly compiler, the state-of-the-art WebAssembly implementation. And what we see here is like just what I said before. The recompiler has a bit of compilation time, but its execution times are like very, very fast. So WebAssembly wasm time is considered to be like top-notch standard, like the best of the best compilers for WebAssembly. And PolkaVM, and this is not even like very well optimized, it just executes this interpreter faster than the fastest WebAssembly compiler. And then what we also see is the interpreter, while it executes a lot slower, it has zero compilation time overhead. So there's nothing missing here. It just doesn't show up because it instantly starts executing contract code, which is again very beneficial if you just, for example, do a token swap which executes dozens of instructions or hundreds of instructions, then you probably want this. And then we see like existing solutions, Solana and WebAssembly contracts. So they don't really excel in neither metrics, right? So their compilation time is like quite high, but also their execution time isn't very something to brag about. And with PolkaVM, we can basically have best of both worlds. So what this does, this unlocks new use cases that are so far not really possible. But so you can just, instead of a parachain, write your code as a contract once the JIT compiler is available, because it will execute around the same time as your native WebAssembly code. If startup overhead is feasible for you, you can also have interpreter contracts for other languages. So we might as well see Python or JavaScript, or like, Move or Solana contracts on Polkadot Hub. And if you, let's say you want to verify a Stark proof, and then what you do on Ethereum, you always have those recursive snarks, because there's very few curves, and so very few verifiers that actually work on chain. And then you always have to verify.
Hello, hackers. Welcome back to yet another live stream. This one is not going to be a workshop. We already have two of them. Today, we'll be having the first ever AMA session, and that will be followed up by live demo, which will be taken care by Abhiraj. So we'll see not just one, but two live demos specifically dedicated to Solidity as well as Rust hackers. So let's start with the AMA part first. But before that, we'll quickly introduce our new guest for the day. So Parth, who is, okay, here it is. Hello. So Parth Mittal is one of the PPA grad, just like Abhiraj and Raj, and he is currently working at Oracle. He has been like ETH India hacker and winner for 2 times. So he has like lot in his portfolio, and he will be joining us today as the mentor for the AMA and later as judge as well. So welcome Parth for the first ever time in this live stream.
Hey, thanks, Shankar. Happy to be here. Thank you.
And the guy who needs no introduction, Abhiraj from Montauk Lab, will be also helping you with the AMA questions, and I will be the moderator for this session. So, without any further ado, we'll basically get started with the questions right away. So, hackers, this is your time to start asking the questions, and we'll go through them one by one. But so far, what I would do is, I guess a lot of hackers will be writing questions now. So I will ask one question to start with. This is a question to Abhiraj and Parth. They are pretty active in the Discord channel, dedicated hackathon Discord server, as well as the Students Collective. So they have been mentoring a lot of hackers for last 5 days. And today is like fifth day, which will be like fifth day will complete at 11:30. So we have just 2 more days to go. And for the hackers, what's the feedback so far from the hackers? Abhiraj or Parth, anyone would you like to like give like some insights? What are the feedbacks that you received from the hackers? What type of questions you got?
Okay,
Mm-hmm.
I'll go first. Different kinds of projects. So mostly people were DMing for validating their ideas,
Hmm.
and we saw different like the ideas were spread across various domains. So we saw from CLI tools to ZK proof solutions, and also saw someone in doing NFT projects.
Mm-hmm.
So yeah, people were doing various things, which were very interesting. Okay, one of the projects was
Yeah, I think Abhiraj is stuck.
Yeah.
So I think
Okay,
by
Parth,
the
would
time
you
it comes
like
back,
to? Yeah.
I can continue. Yeah.
Yes, please.
I think similar feedback from my side as well. Pretty people are very enthusiastic first of all, and a little bit of frustration also at points, which is okay. Part of the hackathon, and yeah, I do like the enthusiasm. People are trying to figure things out, and I think figuring out is like the most underrated skill. So um, yeah, I think it's going well. Some hiccups here and there, some technical difficulties, but I think overall people are putting in great effort and trying to get figure things out. So it's going well.
Mm-hmm. Mm-hmm. Got it. Okay, so the next follow-up question that I guess most of the hackers might be interested in, right? So, what does the competition looks like from the perspective of a judge or mentor?
I mean, it's better if you don't think about it, right? From a personal experience, when we first started doing some of the big ones like Eat India, when it
Mm-hmm.
was our first time, we were quite overwhelmed with the people. Someone has done that fellowship, someone has won that hackathon. People wearing jerseys from X university, X hackathon winner, etc. It's quite overwhelming. We didn't think that we would actually be able to submit a good project and eventually even win. So don't think about the project. I think after that, I sort of understood that uh, don't think about the competition, and nothing is sort of uh, unachievable per se if you're figuring things out, right? So yeah, diplomatic, but that's true.
Yeah, got it. Okay, back to Abhiraj. Abhiraj, can you hear us?
yeah, am I audible?
Yes,
Yeah.
loud and clear.
So yeah, yeah, I was saying that yeah, people faced issues some in the pass it up connection, but I think eventually everyone resolved those issues. Yeah, and now everyone is on the track for getting their contracts deployed. Yeah,
Mm-hmm. Mm-hmm. Amazing, amazing. Talking about the Asset Hub, or you could say like Passio Asset Hub, right? So
yeah,
there is an upgrade upcoming, or it's already done, which actually going to change the chain ID, right?
yeah.
So
I
is
think
it
the chain ID is still working. Yeah, the old one. Yeah.
okay? So the
So it's
upgrade
still,
is upcoming, right? So at
yeah.
one point, hackers have to change the chain ID, and they will be facing connection issues. So if you face, if you were wondering, oh, it was completely working fine, absolutely, and out of nowhere it's giving me connection issues with the network, then just increment the chain ID by one, and that should be good to go.
Yeah, we'll put up an announcement as soon as we notice the
Hmm.
upgrade. Yeah.
Perfect, perfect. Oh, by the way, Abhiraj, you missed one question which I asked to Path before you
Okay.
joined. So that question was about what does the competition looks like, and this is like maybe what most of the hackers might be interested in
Hmm.
to know from a mentor and judge. So Parth gave a really good answer that it's better if you don't think about it. But do you like to add anything to that?
Yeah, I mean, fair enough. Don't think about it. But yeah, the competition is good enough. Like I have seen ambitious projects, some people DMing like while validating the ideas. So yes, projects are very ambitious, and people are going to. I mean, the brainstorming that they have done is quite interesting. Yeah.
Mm-hmm. Got it, got it. Okay, interestingly, we haven't got any questions so far. So, guys, if you are listening to us on YouTube or the Twitter live stream, feel free to ask the questions in the chat. Okay, as we don't have the questions, how about we go through the one of the two demos, and then when we'll get the questions, we'll quickly shift to the question section, question AMA part, and later back to the second demo.
Okay. Okay. So before going to the demo, I'll just brush up on the uh, PolkaVM slides.
Mm-hmm.
Okay. Present. Okay. Yeah. Is it visible?
Yes.
Okay. So most of this was covered by Raj actually, but I'll
Mm-hmm.
just brush up in so that people are on the same page. So the Revive palette. So the main objective of the Revive palette was to introduce the Solidity smart contract support and the tool compatibility with Ethereum ecosystem. So the way this works now is that we have a Revive palette and a proxy server attached to it in the Polkadot SDK. The reason for this being that they didn't introduce it in the runtime itself because then the client would need an upgrade. So they had the proxy server separate from the SDK. So this proxy server acts as an Ethereum JSON RPC server, which collects the transactions and then sends to the Revive palette for execution. Okay, so PolkaVM is the new VM that Polkadot has launched. It comes with the RISC-V architecture, which is a register machine. So unlike many VMs which are stack-based, like the EVM EVM basically is a stack-based machine. So how it works is it has an infinite stack, and when you send instructions, they go into that infinite stack. While finite register machine is a bit faster because it already has like a fixed amount of registers and it knows what is coming when. Okay, so interpreter and just-in-time compilation. The just-in-time compilation I think is not yet fully implemented. Currently, we have the interpreter. So small contracts get interpreted quickly to RISC-V, while the larger ones take a bit time. Some people I think even face this latency and also put up a uh, put up a statistics that the EVM is a bit faster, I think, than the PolkaVM right now. It will be solved, I think, when the JIT compiler comes in. So yeah, this replaces the EVM on Polka. Yeah. Regarding performance, so EVM by default uses the 256 bit words for its architecture. PolkaVM relies on the 64-bit word length. That makes things and operations a bit much faster. Yeah, this is the workflow. Solidity is converted to Yule, which is the intermediate low-level language compiled by Solc, and then the Revive palette compiles Yule to RISC-V instructions. Yeah. So people might have noticed that there's different remix IDE for the normal Ethereum chains, while there's a different one for the Polkadot. The reason being that LLVM is being used to compile down yield to RISC-V, and LLVM is a bit hard to or resource heavy to run in the browsers. That's why the Polkadot Remix has a separate backend that runs your contracts, that executes your contracts into RISC-V. Okay, so I think that's about it. This is the Polkadot's vision for smart contracts, for faster execution and writing business and their business logic in Solidity, and their integration with the EVM ecosystem. Okay, so it's a quick brush up. I'll share a simple smart contract that we will try to deploy on the AssetHub. Okay. Okay. So is my screen visible? Hello.
No, not yet. Can you please reshare, Abhiraj?
1 sec. Yeah. Okay.
Yeah.
Okay. So here we have a very simple smart contract. I made it simple because we want to just show deployment. So how a basic smart contract works is we have the license line, then we have the Solidity version, like you mentioned, what kind of like what the version of your Solidity program is going to be. So this mentions that it has to be more than 0.8.0, and then we start with the contract. So contract name, and then we declare our variables. So this smart contract is a very simple one, which just updates a number, and then we can retrieve the number. Stored number is our variable. It's private. The reason it's private is because we don't want other contracts or other users to directly access the number. Okay. So the first function is store. This function is a public function because obviously we want the public function to be able to interact with this function, and we store a number that's given as a parameter. So function just stores the number in the stored number variable. Then we have the retrieve number, which is also a very simple function where it's a public function, returns view. That means it's just a read function and returns a uint 256. So we just return the stored number. And third is the increment function. Function increment public. We don't need any return statement or anything. So we just increment the number. Okay. So what we'll do is we'll try to deploy this using Polkadot Remix. Okay. We'll go to Polkadot Remix. Yeah. Okay. Before that, we will make sure that we have the AssetHub added to MetaMask. Yeah. So this is the AssetHub. We can see its details. Network name is AssetHub. The default RPC URL, we have shared this in the Telegram channel, and the chain ID. So one thing interesting about this is that AssetHub shares the same chain ID as the West End Hub. So some people faced that issue when they had already added the West End to their MetaMask. They had to remove the West End and then again add AssetHub, so to avoid conflict issues. Then we have the currency symbol and the block explorer URL. Okay. So once you save this, and we can go to the faucet. I've actually gotten some tokens beforehand, so we don't need to worry about that. Okay. So what we'll do is now we are in Polkadot Remix. We'll go to contracts, and let's create a new file here. We call it storage. Okay. So just paste alert. Okay. So we have the function here. So we have the smart contract here. What we'll do is compile the smart contract using the Solidity compiler. Yeah. Okay. So it has compiled the contract. You can see a green tick over here. Now we'll try to deploy it. So before deploying, you want to make sure that your MetaMask is on the same network that you want to deploy to. In our case, it's the passive hub, and you have enough balance. Okay. So we wait till it finds the network. We select inject provider MetaMask here. Okay. Reload this. Okay. Okay. Not sure why it's not
Can
recognizing
you
the wallet.
try a different browser?
But I have tested on this.
Mm-hmm.
Should work.
Try incognito.
I don't have the wallet. Okay. Is it
Wallet will still say.
oh, okay. So let's try.
Command Shift N.
Polkadot. Remix.polkadot.
Remix. Yeah.
Let's see. Okay. Let's try compiling an existing one. Okay. Oh, I'll have to activate the extension. Is the Polkadot remix working? Can someone check?
Yeah. Meanwhile, you can try Command E. I think Command E opens the extensions. And
I enabled it. Yeah, okay. Okay. So we'll make our new contract over here. Storage as well. We copy our contract code. Okay. Then we compile. Okay. Now to deploy, we just make sure that the injector provider MetaMask is the environment, the account is there, and we press deploy. Okay. Send transaction. Confirm. Okay. It's Ethereum mainnet. We make sure that the network is AssetHub. Okay.
sometimes not having funds is good.
No. Okay. So a transaction has been executed and you can see the deployed contracts over here. Okay. So we can interact with the contract right here, can test it. Let's transact, we store the number 5 initially. Wait for the transaction to happen. Yeah. Okay. Yeah. Now you can retrieve. It shows 5. You can also do an increment. And then retrieve again. We'll wait for the transaction to happen. Yeah. Okay. Now it's 6. Okay. So that's how you deploy to AssetHub and test your contracts. Yeah. Okay, I'll close this.
Okay, that was an amazing session. Thank you, Abhiraj, for that.
Yeah,
Um,
I think Polkadot Remix has some yeah issues with the MetaMask. You
mhm,
can
mhm.
yeah,
Yeah.
or maybe
So
it's
the
the Ask browser.
thing is, we actually had a front end session yesterday with Haoyang, and this is exactly what most of the hackers might be needed if they are just getting started with the Web3 development. So, as
Right.
you are already familiar with the template that Haoyang shared, you can now just grab the ABI from the remix over here along with the contract address, and you are ready to go. So it's that simple. And that
Okay.
was the first demo out of the two ones. We actually got one question, so we'll quickly shift to the AMA mode. So this question is by Zist. The project he is building, it is somewhat solving a problem that exists in the main mainnets and not considered in the testnets. So you will to test and you will have to test and verify it. Is it okay if he gives away the testing of it and verify it, and also add a demo video in the bidl submission?
Not entirely sure of what he's asking here because not considering testnet, so we will just verify it. I mean, yeah, demo video should be good, but it is better if you can give us the deployed contract address at least. It doesn't have to be. I mean, yeah, as long as it's a deployed address, that's good enough. But if you want to rephrase your question, go ahead. We can take that again. If that did not answer your question, yeah.
Mm-hmm.
Yeah, I think when he's taking a video, he should be deploying on the mainnet, so he should technically have an address. Right?
Oh, mainnet or testnet? Well,
I think his project only works on mainnet. If I understood that correctly.
no, I guess the problem that he wants to demonstrate only exists on the mainnet, right? So even if he deploys on the testnet, he might have to have some kind of contracts to automate some kind of
Hmm.
data or fades which simulates the mainnet like parameters. So will that be
Okay,
fine if
and
he
that's
does?
what he'll show in the video, right?
Yeah, I guess so.
Yeah, that should be okay, I think.
Yeah.
As long as you can show that in a video and also probably give some instructions. Yeah, as
Okay.
long as you can simulate it, that's good enough.
Yeah.
That works.
Mm-hmm,
And
mm-hmm.
if you can provide instructions as to how to simulate it, even better. But a video is super important in general for any submission. Uh, so yeah, this should work.
Amazing, amazing. He has a follow up comment. Is it around token price fluctuations, which he will be simulating on the testnet? Okay, so it is kind of a simulation of parameters.
Yeah, it works.
Yeah.
Amazing, perfect. So this is, I guess, a feedback for everyone, right? If you can simulate minute like parameters somehow, that's actually a plus point, not a negative point, because that actually demonstrates how it will your project's gonna work when it's actually launched on the mainnet.
Yeah, also adding from here, I personally consider a video extremely important.
Mm-hmm.
So do not miss out on adding a video in the README, and keep it short. Don't keep it too long, but try to give a good video. I think your video is the first impression to your project. So give a pretty good video. We have seen that both of us, whenever we are in a team, we kind of keep postponing it at the last moment. Don't do that. Even when you're like 5-6 hours away and you think like at least 80% of your project is ready, make a video, keep incrementing, keep building on it later on for that 20%. It's not going to change drastically. If you have some working solution, please make a video. You never know when it stops working. So make a video, keep it ready, and submit it. You can always edit it, but highly recommend to make a video 5-6 hours before the final deadline.
Perfect. That was a pro advice for all the hackers. Okay, we don't have any other questions. If we have any, we'll again go back to the AMA mode. Again, all the hackers, this is an open call. You don't have to wait until the moment where we'll say, okay, it is open for question. You can ask questions even while demo is ongoing. So we'll switch back to the demo mode. Moving on to the second demo of the day. This one is focusing for the Rust developers. Back to Abhiraj.
Yeah, I'll share my screen. Okay. Yeah. So this one is for people who have complex smart contracts or heavy calculations in the smart contract. What you will want to do is clone this repo. We have shared this one in the announcements, the Rust contract template. Okay. So basically what this repo allows us to do is it allows us to deploy a Rust contract, which comes with the extension of .polkavm, as I'll show over here. Yeah. And what you can do is you can shift your complex logic to the Rust file. Okay. So this is kind of out of um, like you won't have to deal with this. Like this is pretty much advanced stuff here. What I would suggest you to do is keep this repo as it is, and what you need to know is that this function, the call function, that is in the main.rs file, is the function which your Solidity interacts with. So basically what this does is this function strips out the important part from the Solidity call. So okay, before that I'll just give you a simple example how the contract would look like. Okay, so we'll take the example one that they have given is to call Fibonacci function from a Solidity contract. Okay. So interface iris contract, this is how you define other contracts in a Solidity smart contract. So you can call them later on. Okay. Then we have started our contract called Rust. In this contract, basically we have a function called function Fibonacci. This one is an implementation in Solidity itself, and this one is a implementation in the Rust. So basically, Fibonacci Rust, what this function does is it calls the Fibonacci function from the Rust contract. Okay, and now when we deploy this contract, we would need to mention the address of this Rust contract. Okay, and how will we get that address is by deploying the Rust smart contract. The thing is, with Rust smart contracts, you cannot deploy it using the Polkadot remix. You have to deploy it using the terminal itself. Okay. And to make a Rust contract yourself, you need to clone this repo, go to the main.rs file, and okay, do not touch this function, the call function, because what this function does is it handles how the Solidity calls a different Solidity smart contract. So what it does, it strips out the main data from the file, okay, which is the input. Right? And then what you need to do here is you mention your function that you are coding out, like they have mentioned the Fibonacci, and then define this function below. Okay. So this is how simple Rust implementation would work. Okay. And okay. So what we'll try to do now is we'll try to deploy this Rust smart contract. It's very easy. First, you need to install Polka tool. Install cargo install Polka tool. I have already installed it. So once you have installed this, you make sure that you are in the same repository as or in the same directory where the project is, and just use make. Okay. So once make is done, what it does is it will give you this file. Yeah, this one, the contract.polkavm. Okay. Now this contract.polkavm, the revive palette can directly handle this. Okay. The contract.polkavm file, we need to deploy this. You can treat it as a .sol file. Okay. Just that it's a Rust contract. Okay. Now to deploy this, you need to have Foundry installed on your device. I'll be sharing how to install Foundry in the announcements later. But once you have Foundry installed, you will have something called as cast. Okay, so what cast does is basically it is used to deploy, it is used to estimate gas fees, etc. of the smart contract. Okay, so before doing that, what we'll do is we'll make sure that uh, our private key and our public address uh, is added to the environment. We'll just export these. Yeah. This is the ETH RPC URL of the AssetHub. Okay, and we'll also export our public address. Okay, this is my public address. You can copy it. It doesn't have any funds. Okay, what we do is we import dev account from the private key. So what this cast does is it creates a local wallet. Okay, so mine is it already exists. What this will do for you is create a local wallet in the .foundry folder. Okay, so what we'll do now is we'll deploy this Rust contract, which is contract.polkavm. Okay, so yeah, we do this. What we are doing is basically we are storing the address that is written by the cast statement. So to deploy, we use cast send dash this account, dev account, and then create. Yeah, this is the command that is used to deploy the Polka VM. Okay. Okay. We entered the key store password. Yeah, take some time to deploy it. Okay, so once that is done, we can do a simple echo on Rust address, and it will return the smart contract address that is of the Rust contract. Okay. Now what we need to do is we need to deploy our Solidity contract. Okay. So this is our Solidity contract. Right. What we can do is we can deploy this using Remix. So we just copy this, and go to our Remix. Okay. Create a new file. I'll call this Fibonacci.sol. Okay. Okay. Then, yeah. Okay. And we compile. Once it is compiled, oh, it's facing the same error. So we'll try this in incognito. Okay, we compile. Yeah. Okay, and then we deploy. Um, yeah. Okay. Okay. So our smart contract has been deployed. It's called call rest. Okay. Now it has two functions. One is the Solidity implementation of Fibonacci function, and one is the Rust implementation. We can check both of them work. So the first function won't require any smart contract address, right? Because it's just a Solidity implementation. We just call it, okay, and it return 2. We'll call this one as well. You can see this one requires a Rust lib address. Now this address is the Rust contract address that we just deployed. It's this one. You can paste it over here and then call it again. Okay, and you can see that it returned 2 as well. So our smart contract is working fine. Okay, so we'll do something more on this. What we'll do is we'll compare their gas prices. Okay, so to compare gas prices, what we'll do is cast estimate. Okay, so we have this command which is cast estimate rust address. It's the variable that we stored our rust contract address in, and this is the function call. We call Fibonacci UN32, public pure returns UN32, and the input that we are providing is 4. Okay, okay, so this is the gas fee that we required. Okay, so but we don't have the Solana address. Sorry, we don't have the Solidity contract address on our device. So what we'll need to do is copy the Solidity address, which is the call rest contract. This one, we store it using some variable. We call it call address. Okay, so we can reference it. Okay, this one. Yeah, and then we can call cast estimate. Same function, and then wait for it. So as you can see, the gas fee for the Rust address is much lower than the one for the Solidity address. That means that for complex functions or functions requiring good amount of computation, you can use the Rust contracts, which will reduce your gas fees immensely. Yeah, so that's how you deploy Rust contracts. Yes.
Perfect. That was a great insight, especially if you like already leveraging the benefits of PolkaVM, but you want to go a step further. You can go with the Rust contracts. And I guess nowadays we have seen increased number of Rust developers in India, which was very rare a few years back. So I guess a lot of developers might choose to go with that path as well, and that
Yeah.
could give a lot of benefits to them and to their project. Okay, do we got any questions? Nothing so far. Parth, back to you. I would like to ask you about what would be the pro tips would you give to the hackers. So this is the question that I asked to Aviraj and Raj in the first mini workshop. So that's something I would like to know from your perspective as well.
Okay. Yeah, I think one was the video that I've shared. The second would be that a lot of people ask, when you validate your idea, And I've generally seen people, trying to put in a lot of stuff into the idea and trying to get everything done. A quick way to analyze whether you would be able to achieve it is that think about presenting it in a video, and if you can present that feature in under 3 minutes, including your problem, including your solution, including the demo of at least the MVP, then add it. Otherwise, do not add it. Right? That's a simple measure. Even if you somehow have enough time to add it, you will not be able to present it. And if you can't do that, there is absolutely no point, right? So please focus just on the MVP, just the core logic. And if there are features that supplemented, you can add it later once you have your working main part ready. Right? We've seen this time and again. People try to focus on multiple things, and then the core feature itself is left behind. Right? Just focus on that, and uh, once that is ready, think about the other features. Yeah.
Amazing. That second point is really important. And as a, like, when I used to do hacking, right, quite a while back, so I also used to miss out on this exact thing. And at the time of integration, it would have been chaos. So this is something a lot of hackers will relate to and could take advantage of with this newer approach. Okay, we got one question. This one is from Arav. How different is building on PolkaVM than from EVM? And how do we use AssetHub? Is it simple as changing RPC URL? Abhiraj or Parth, would you like to take this one?
Yeah, Viraj, you want to go? Otherwise,
Yeah, I'll add some stuff. So yeah, so building on Polka VM offers you much more opportunities and in terms of how you can develop your smart contracts than EVM. And if you look at it like that, like yeah, obviously it is as simple as changing RPC URL. Yes, I mean if you want the similar functionality that comes with EVM, you can just simply change the asset hub RPC URL in your MetaMask and deploy contracts. But it has more to offer than that. Just like before you joined, I think we did the Rust demo. You can implement Rust, and it has much faster execution speed, and also the Polkadot ecosystem that it opens to. So these are the advantages that it has.
yeah, just to add a little bit on, I think what he's asking is, as a developer, how different it is. I mean, Abhiraj is on point when he's saying there's much more to offer in what PolkaVM is offering. But as a developer, I think just to give a slight history, till now you could not deploy Solidity contracts on Polkadot directly on Polkadot. You could do it on a parachain, but otherwise you would have to write a contract in Ink, which is based on Rust. So now what PolkaVM offers is you can have the same contract written in Solidity, and as simple as changing the RPC URL will natively work on Polkadot as well, thanks to the pallet-revive, right? And I mean, simple analogy is that your Ethereum is one DVD player, and you have a bunch of contracts which are DVDs, and PolkaVM is your Blu-ray player, right? And you can't anyway play these DVDs in Blu-ray, but the pallet-revive is like an adapter that lets you do that. Right? So you can now play these same DVDs on Blu-ray as well. Right? That is the analogy.
Amazing. That was really an OG analogy, I would say. So you mentioned ink contracts, right? So what if there are ink developers who are looking to participate in this hackathon? And I guess with ink version 6, they would be able to deploy on Polka VM as well. So any advice for them?
Yeah, I mean, feel free. If you are seasoned enough to take on the challenge of writing ink, go ahead. As Abhiraj mentioned, I think Rust gives you faster and lesser gas fees, so that is definitely an advantage for bigger contracts and computationally heavy functions. So yeah, feel free to do that. I think if you can, please go ahead. But as a beginner, I would suggest sticking to Solidity if you want. But there's definitely a guide where you can translate from Solidity to Ink. There are steps that you can follow that this thing translates to this type of function in Ink, and you can write a contract in Ink as well. So yeah, feel free to do that.
Got it. As Ink is like a framework of Rust only, will there be any like benefits of using Ink instead of the Rust template?
Okay, so you're mentioning that in like directly using ink instead of calling Rust from Solidity. I think it
Yeah.
reduces one more step for the compilation. So I think direct ink would be a bit faster, I guess, than calling from Solidity.
And they can still deploy, like you can still see a contract address on the EVM format and everything, right? So will are the developer toolings ready for it, or is there like a gap which might add like hindrance for the developers who are looking to participate in this specific hackathon using Ink development stack?
I think the Solidity docs would be obviously much more better than the ink docs because of the Ethereum ecosystem. As for the calling Rust from Solidity, uh, there's not much docs. As I mentioned, there's only one repo which demonstrates how to call Rust from Solidity. Yeah.
Got it. Got it. Amazing. So for most of the hackers, if you want to start like a simple implementation, and if your contract do not have a dependency on like gas related opcodes or precompiles, I guess you can literally deploy your contract as it is on PolkaVM. But for few contracts, you might need to do slight changes, and those could be even done within an hour or more or so.
Yeah.
But if you want to go a step further, then that's where PolkaVM will actually shine. And if you are building using like any other testnet, let's say any EVM testnet, and then deploying that on the PolkaVM, you will miss out on those optimization or features because obviously if your contract size is a lot bigger on standard EVM or EVM equivalent testnets, then those contract deployment will fail, but they won't fail as long as they are like approx 4 times than the usual size of the standard EVM on the PolkaVM. So actually PolkaVM offers such benefits which you can leverage if you start your testing right on the AssetHub testnet. So that's again something to keep in mind. And that's all we got. We don't have any further questions. Arav is saying thanks. Any last comments or advice would you like to give, Abhiraj, Parth? What if like there are hackers who just registered and they want to submit in the next almost 2 days, right? So 2 days and few hours. So what would be the advice for them?
Don't sleep.
So I think start with the templates. Start with the templates that we've given. There's one given by the guide that we have, which is at contracts.polkadot.io. That template is pretty good. I think it'll give you all the front end, back end, most of it. So if you are familiar with Solidity, you will get started pretty fast with that. Yeah, don't sleep. Have lots of energy drinks. And also, like, I think a lot of people think that, hey, I'm starting in midway, people would have done a lot of progress. Not necessarily. I don't consider that 100% true. You know, a lot of things were getting figured out in the first 2 days, and you need not compare yourselves with the same you might be much faster, or you might have some more context, or your idea is so good that even with a smaller time frame, you can execute that. So please do it. Please go ahead. Don't think about the competition again. Yeah, and feel free to ask questions on Discord, on Telegram, wherever you want. We'd be happy to help.
Yeah.
Abhiraj,
Yeah. Also
any
for
advice from your
front
end?
end, yeah, for front end, they can use the yesterday's workshop template. I think it has all the details filled in. And I would say you can keep away from like the harder things like calling Rust from Solidity and stuff like that. So you don't encounter much issues. Yes.
Mhm.
And make sure you document everything in README. So even if you are left with no time at the end, your README is still up to date. Yeah.
I think one more thing to add here, which I think people will not find very uh, conventional, is that do not write your README using ChatGPT.
Yeah.
Please don't do that. I can smell it, and I don't like it. Right. So a lot of time it just hallucinates a lot of things that what you wanted to portray is not being portrayed by the README. You're much better, even if you just write points and don't write much big paragraphs. Just give me sharp points. That's more than good. So yeah.
Perfect. On that note, actually, we are good to conclude today's session. Thank you, everyone, for tuning in. All the 46 members tuning in on YouTube or Twitter live stream. And huge thanks to Abhiraj and Parth for guiding all the hackers and the demos. Uh, we got one comment from Ara. He says, he's bad at writing README. What would be the last advice for him?
Yeah, I think it's simple. If you can build something, you can easily write a README as well. Just whatever you thought, put it out there. Don't think about keep it more formal and stuff. As I said, even if it's raw, but it conveys what you wanted to convey, it's more than good. Don't think about the formal English and all that stuff. That's good.
Yeah. Put more screenshots, I guess,
Yeah,
if you can't write much.
yeah, yeah. That's a good advice. Yes, if you can't write, please put screenshots. Yeah,
Yeah.
Can't go wrong with that.
yeah.
Okay, so that's pretty much it for the day 5 and our fourth session, first AMA. We'll have 2 more workshops tomorrow and day after tomorrow. So until the last moment, we are there. And throughout this period, we are available on the Discord as well as the Students Collective Telegram. So if you have any questions, any difficulties, feel free to reach out to us and we'll be there to help you. Happy hacking. See you. Bye.
Thanks everyone. Thanks, Shankar.
Thank you. Oh,